Rotations and Symmetry. Go ahead and put your date in the upper right-hand corner of your paper. And let's start looking at some definitions. So a rotation is a transformation, it's a type of transformation, in which a figure is turned about a fixed point, and that fixed point is called the center of rotation. So for example, if I had a grid, and I had a figure, and let's do something fairly easy. Let's do like a star. And I want to rotate that star. And I'd say I'd already done my rotation, and I had rotated it, and my star was now here. So this rotation was about a fixed point. When I did this rotation, I looked here, and I moved it clockwise to that point. But I rotated it around my center of rotation, which was, in this case, the origin. So this is the center of the rotation. Now to describe this rotation, we need to figure out approximately how far it's moved. Well, to do that, we need to know what the angle of the rotation was. To find the angle of rotation, we're going to go ahead and draw a line, just like I did, from the same point on the figure to the center of rotation. So I chose this point on both of my figures, that's the same point on that star for both figures. And I drew a line to my center of rotation. The angle right here, if I were to measure that angle using my protractor, that would be the angle of rotation. I'm going to say it's approximately, well, let's say 45 degrees. Perhaps not that accurate for my drawing, but so the measure of the angle of rotation for mine would be 45 degrees. To describe this, I'm going to say that this was a 45 degree, and we're going to say I went from the purple to the red, so is it a clockwise or a counterclockwise? Well, sure enough, we're going that way, it is a clockwise, so it is a 45 degree clockwise rotation. Okay, so we had our rotation, which was I took this star and I rotated it into the position of the red star. The center of rotation, the point that I rotated about, and then the angle of rotation, which I found by drawing a line from the same point on both of my figures, on the original figure and on the image figure, and then finding the measurement of the angle between those two lines, and describing whether it was a clockwise or a counterclockwise. In your textbook, the center of rotation will always be the origin if they're using a coordinate grid. So you can just know that right off the bat. Let's go ahead and just look at a couple other situations you might want to think about. Now in your book there are some helpful pages you might want to just take a quick note of. On page 742, there's a really nice description here of the different types of 90-degree rotations. This is a 90-degree clockwise rotation and a 90-degree counterclockwise rotation. Now, trying to figure out how to describe these using coordinate notation can be a little tricky. What you want to do is you want to see from point A in this first figure to point A prime, what happened to those coordinate points? Well, originally it was 2, 3, but after I did that 90-degree clockwise rotation, it was 3, -2. So to write it out using coordinate notation, I did x, y, originally 2, 3, changed. What happened is the numbers x and y actually flipped. So the value that was originally my x value became my y value, and the value that was originally my y value became my x value. So you could rewrite it as y, -x, because you'll notice that the y's, which were originally positive, then became negative. So that's one way that you can show, by writing out the coordinate notation, a 90-degree clockwise rotation. We have the same picture for the counterclockwise rotation. X, y changes to -y, x. Your book recommends that the that might be easiest for you if you just want to memorize these? I would probably disagree. I think that's something that you could figure out with yourself once you start getting a problem. If you get stuck and you need to write something out in coordinate notation, I recommend finding the two coordinates and then seeing what happens with those two, with the coordinates when you get the image. So yeah, it's good to know what they look like. It's good to know how they write it out with that negative y comma x, but I'm not sure you really need to go so far as to truly memorize it. The book also has one other picture about a 180-degree rotation, which is useful. So it says for 180-degree rotation, what happens in your coordinate notation is that it's going to move from one quadrant to the opposite quadrant. So it's going to become negative x comma negative y. Again, don't need to memorize it, but I think it's helpful to know that that's what's happening with those coordinates. So the point here, 1 comma 3, is going to become the point negative 1 comma negative 3 on the image. Good to know, and to know that those resources are available to you, and that one's on page 743 if you want to go take a look at that. There's some good examples in there, but for what we're doing, as long as you got down how to find the degree of rotation and how to notice what's counterclockwise or clockwise and the center of rotation, you're doing fine. So I'll see you in class. Have a great night.